Muted. Okay, I think we'll get started with the lecture now. Hello everybody. Thank you for coming in person tonight. Appreciated for those of you who did. And for the none of you on Zoom. So yeah, this is our second to last lecture for tonight. Hopefully you've been keeping up with like the labs and the vitamins. If you haven't, it's okay. You've got a bit more time to do it before grading's due. Try to get it done before like maybe dead week, I think. But those deadlines will be more apparent on like ed as time goes on. As a side note, I think I mixed up lab 10 and lab 11 because next week you guys are going to be learning about Kubernetes, but the grade scope assignments are swapped. I'll fix that after lecture if you notice that. I'm sorry. I think that is it logistically. Does anybody have any questions about grading the course? What's happening? Is everybody doing well? Pretty good assignment wise. Okay. Good to hear. So tonight we will be learning about config management, in particular, a tool we use at the OCF called Puppet. Before we do that, I wanted to mention we are looking for facilitators for next semester for the DeCal. So if you guys enjoyed the DeCal, felt like you learned a lot, or if you've ever thought to yourself, like, why did they do it like this? They should do it like this instead. This is like not well implemented, or you change this thing about the lab. You should join and like fix it and help run it. I just took the DeCal last semester. Now I'm running it. So there is definitely like room for improvement in terms of like, if you thought about TAing for different classes, like 61 or 61B, it's definitely be a very different experience, but you'd also get a lot more control. So, and like say in the content, how things are run. So there's my pitch for facilitating. I'll probably send out a form before the end of the semester, so that way you'll be notified. Yeah, I think. And also you get like 1 unit for facilitating and 2 units for running it. So it's not totally uncompensated. It is uncompensated in terms of like salary, but you get units. So, and it's not too much work. You just have to give like 1 or 2 lectures, learn it, help people out of the lab. Yeah. So let's get started with Puppet. Give me logistical questions about how things are going. Oh, no, you're good? Okay. Then I guess we'll get right into the content of the course. Also, if you want to facilitate next semester, I'll send out more information about that soon on ed in the next like weekly announcement. Yeah, I think that's all you missed. So now we're going to be learning about Puppet. So after all you've learned in our wonderful SysAdmin DeCal, you've been hired for a job. You've earned your Open Computing Facility fully fledged Linux expert certification, TM asterisk, and now you've been hired to manage a computer lab. How do you go about doing that? Because you're going to run into some issues, such as managing a fleet. And by that we mean a fleet of like both desktop computers and servers. So let's say that like you have a bunch of computers and the people want Minecraft. Okay, how do you install Minecraft on all of the desktops in the computer lab you run? Are you going to go from each desktop manually and go download the Minecraft launcher and installer? Are you going to, maybe you remember the content from lab 1 and you're like, okay, bash scripting. I can write a script that will SSH into each desktop and install. Or you could just sit there aimlessly and wonder, how do I deploy updates to a fleet of existing computers? But luckily there exists a tool to do that, which we'll find out in a moment. Or so, let's say you run into the problem of provisioning new machines, right? So we buy a new desktop for the lab, or actually we're going to be buying many new desktops for the lab. We've already bought a few of them. And you want to set it up with the exact same configuration as the ones that already exist. Sitting down with like a list of software that needs to be installed on every desktop and configuring each program to run exactly how you want it to is kind of difficult. and takes a lot of time for each individual machine. For example, if you want Minecraft to continue with that, to use more than 1 GB of RAM on each machine, you have to go through not only install Minecraft, but also configure it to use more than 1 GB. And finally, the third problem, communicating changes. Say you're running a Minecraft server and you realize some change you made long ago broke a thing. How do you figure out what settings you changed around that time? You know, how do you communicate changes in software configuration to future you and others? You can't like go through in the past and see what you had changed very easily, right? If you go through a NeoVim and you go and change a configuration file and leave it and forget about it, it's hard to go back and find out what exactly you had done. But luckily, there exists such thing as config management. So you can manage the infrastructure of your servers, or in this case, desktops. We also have like 10 servers, which also run Puppet. So if you aren't running a computer lab in particular, you'll probably find a situation maybe where you need to have several servers all running the same stuff, same infrastructure, configured the same way. And so here at the OCF, we use Puppet for some of that. You can see here, someone had made a commit to add a Minecraft launcher to a Puppet configuration file, and all you had to do was go in at the file. This is on GitHub, like public, add in the Minecraft launcher. That was it. Didn't have to think much more about it. And then suddenly the Minecraft launcher is installed on every desktop in the lab. Yeah, Puppet in particular makes it easy to bootstrap new machines, configure running software, allow configuration to be stored as code, configuration as code philosophy, or using that philosophy. It's also known as like infrastructure as code. And it just makes it easier to like, again, update computers by having unified update mechanism, which is in this case writing Puppet code. You don't have to like think, that hard about configuring different things. Number 2, bootstrapping new computers by having all the changes necessary in some centralized repository. When you install a new computer, you can just have a Puppet run go through, it'll ask for updates, you get everything you need. And then finally, you're able to store all of the changes you've made to your infrastructure using in particular Git and GitHub, the tools we've taught you, but you can use, of course, other tools. However, storing the way you have, I don't know, using Puppet code makes things a little simpler. Yeah. And so, yeah, in terms of, does anybody have any questions up to this point about what I've said? It's all pretty conceptual stuff.
I guess you wouldn't have to get pull from everyone on the machine whenever you want to reset a configuration, right?
When you want to reset a configuration.
Or when you want to change the configuration on the
machine. No, what happens is like, I'll get into in a second. There's like this thing called the Puppet run that happens. Yeah, so Puppet is a declarative language as opposed to imperative language. The imperative approach would be, again, say SSHing, writing a bash script to SSH each machine and install the Minecraft launcher. Because again, you're going in and telling each computer exactly how to set up every configuration files and so on, its infrastructure, each like step-by-step process. Install Minecraft, then add a line config file, then run Minecraft. But Puppet code, which is how you use Puppet, is declarative, like say the Docker files you learned about last week. I'm quite sure those are declarative, or like the or SQL, MySQL that you learned about in 61A if you happen to take that class. Again, you tell the program, you say exactly what you want, and then Puppet takes care of the rest and makes it happen without you having to worry about the how as much. So in this case, you say ensure Minecraft is installed, the config file has line X in it, and ensure that Minecraft is running. And then Puppet will go through and make sure that happens. And yeah, this is like a timeline of, like on the left, we've got like, even though Puppet is like technically declarative, we call it declarative, it's not fully, I guess a declarative language. There are outputs that are declarative, but we're not going to get into that today, or you can use it like that. On the right, I guess we've got the more declarative ways to do infrastructure as code, and on the left we've got like Chef or config management. Chef, SaltStack, Ansible, Kubernetes, Terraform are all other configuration management tools you can use. You'll actually be learning about Kubernetes next week because that one is a little more industry wide, like used or applicable today. Again, Puppet's a little bit older. It was made in like 2004. Something like Terraform was made in like 2014, I think, and Kubernetes is way more modern. But I think I also found number one, our Kubernetes lab is like not as fully fleshed out as the Puppet lab, and so when I took the class, found it a little more difficult. So it's the optional lab you can do next week if you want to. Yeah, but these are all other tools you can use. Yeah, so there's some stats from a developer survey done in 2023. 19.02% of people use Kubernetes, 11% use Terraform, 8.6 use Ansible, 1.12 use Puppet, and less than 1% use Chef. Yeah, so if you're really interested in learning Kubernetes, again, I'd highly recommend it. It can just give you a lot. And Puppet's like a good way to kind of get a little more comfortable with some more SysAdmin material before jumping into that. Also, I think this lab is very fun. You get to make a Minecraft server, which or like declaratively create a Minecraft server. So using Puppet. Yeah, so let's learn it. Or how to use it. Before we go into that, I did want to say all the stuff you've learned so far in SysAdmin DeCal, I'm sure you don't feel like fully confident with it. A lot of the material are like using things like bash scripting, Docker, again, Puppet. I would highly recommend you start a home lab, which is just essentially like your own, because again, you're not going to have the DeCal VMs forever. Unfortunately, we will take them away from you when the semester ends. But I would highly recommend you either like buy your own VM from like some cloud provider, or maybe even build your own. And by home lab, I mean like, yeah, you can like use a gaming PC, like just consumer hardware parts. You can use an old laptop, and you can just like get started playing around with this stuff at home, implementing best security practices so your like home Wi-Fi doesn't get hacked or something. It's like a really good way to learn, and you can even like put it on your resume and stuff like that. Or it's a good way to like mess around with this stuff and break things that isn't in the setting where you will lose your job, if that makes sense. I started home labbing maybe like last semester, like over the last summer. I built the computer to do it. And it's been like really fun. I've learned a lot. I like you can set up like a personal website. You can have like your own self-hosted version of YouTube that's like more privacy friendly and open source or something. You can have, again, a place to store like backups of your laptop. There's lots of like, even just day-to-day personal uses of what you've learned here, even if you don't end up using it in your career. And home labbing is a good way to do that. And I would highly recommend you give it a shot. And again, it doesn't have to be expensive. You can use an old laptop. You can use an old PC. So you can get like a really cheap cloud VM that's like a couple bucks, maybe a little more a month. Yeah, does anybody have any questions related to that? Before we move on, just like a brief intermission. I highly recommend you guys. There's like r/self-hosted. There's a whole subreddit for it. There's an old facilitator. I think I'll add a slide about this later. Named Ben Kwan. He has some really good guides on like getting your home lab set up, and doing that sort of thing. benkwan.me. Yeah, I'll add a slide with this after lecture. But yeah, let's learn Puppet. Oh, and if you run a home lab, you can also run a Minecraft server using all this on there. Okay. So Puppet was released in 2005, not 2004. It's like around when most of us were born. It has open source and enterprise closed source versions. Again, like I mentioned, declarative philosophy with some imperative components when necessary. It's not fully declarative tool. It was originally built on Ruby, but now has its own configuration language, like I said, called Puppet code. And it has this thing called a pull model, where configure machines, this gets back to your question, ask for an update. So essentially you have like a cron job that runs and asks your main puppet, your puppet master, like, hey, is there anything new for me to do? Is there any like configuration files that have changed, anything new to install? And that host machine will go, yeah, actually there is. And there's like a whole cycle to it. Yeah, Puppet's used at places like the OCF, CS162, or at least it used to be, Wikimedia, even like by GitHub and Lit, these places all use Puppet. I have to double check if they still do. Yeah. So what happens when this so-called Puppet run occurs, or when, so first off, you have your client, which asks the server for an update. For example, I want to be configured as a Minecraft server. So one of the desktops here asks one of the servers in there if anything is new. And the server goes, okay, well, first I need some information about you, such as send me your host name and your RAM. The client responds with these facts. Well, my host name is zombies.ocf.edu and I have 4 gigabytes of RAM. And based on these facts, the server will cook up some configuration, such as ensure the Minecraft server is running with hostname zombies.ocf.edu, 4 gigabytes of RAM with this configuration file. And then finally, the client makes the necessary changes to ensure its current configuration matches the configuration given by the server. In this case, the Minecraft server is currently running. The configuration file has been updated. I will fetch the updated version. So yeah, that's the general process. Does that make sense to most people? Pretty straightforward. Okay. There's also like some diagrams. I hope. Yeah, here we go. That displays this a little more visually. Except in this case, it calls the client a node, and the server is the puppet master. So we at the OCF have like our puppet master. So again, you've got I think in this case it's slightly different. So first off, the node sends facts. Puppet master sends a catalog that specifies how the node should be configured. Node sends a report. And then you've got like your Puppet dashboard, and then Puppet's open API can also send data to different tools, which is a bunch of other extra fancy stuff. If you want to like start having reports on like how everything is doing and if things were configured correctly. But you're not going to touch on that today. So yeah, how do you write this Puppet code? Well, you've got files, which again contain just static files on your machine. Again, it's like writing a Docker file. There are templates, and then there are manifests, which is the heart of your configuration. Most of this lab will consist of you writing a Puppet, I believe, like a manifest. Yeah. There also, you may feel the need to like write custom facts and like modules and things. And then finally functions if you need something extra fancy, data structure, manipulating related stuff. And then of course you've got dependencies. You have to describe these explicitly because Puppet's going to try to run code in any way it sees fit. And if you have code installing something like Minecraft or running Minecraft, you need to tell Puppet to install Minecraft before running it, for example. Or that you have to have a certain user created before you can create its home directory, something like that. So here's an example of some Puppet code, what that looks like. What do you guys think this does? Do you have any opinions? Like a broad guess. Yeah, it does. It creates the user OCF TV and creates a home directory for that user. Specifically, even though it says file, it's in fact creating a directory. That's what the ensure part does. Here, I'll go through it step by step. First, it creates the user, creates a comment, specifies where the user's home directory is, decides what groups the user is in, and then also specifies that it uses the bash shell as opposed to like ZSH or fish or something. And then it creates a home directory, in this case, the directory opt TV. Ensures the owner is the group is the user OCF TV, the owning group is OCF TV, and it requires the user OCF TV again to be made first before it creates the home directory. This is important or else things will not work sometimes. And this specifically is code we use for the NUC, or we used to use, we kind of switched it up now. We used to have a NUC behind the TV, which is like this little mini PC that ran, like, instead of hooking up my laptop, we actually could just like SSH in the TV and run things. And we still use that for like a lab map and stuff. But yeah, so does anybody have any questions about this set of Puppet code before we move to the next, about what any of it does? This one's pretty straightforward, I feel. Doesn't matter what order you do this stuff in, like in the file itself, because it's declarative. What really determines the order of like how Puppet does things are these like lines like require. I think there's another one you can also use. I think it's subscribe. Yeah, there's some like nuances.
And so require refers to that you have to have a user called OCFTV.
Yes.
Okay.
And then it creates the home directory.
Okay.
But if it tried to like create the directory and then have the owner be a user that doesn't exist, I don't think it would work. Wouldn't run.
So just, it doesn't run order, because there's some like requirement.
Yeah.
Okay.
Essentially. It'll do things in any way it sees fit. Yeah, so here's a second example of Puppet code. I'll ask you again, what do you think it does? I'll give you a second. Think about it. You mean to zoom in? I can. I know it's like 2 pixels large. Will it let me zoom? No. Okay, whatever. I'll just tell you in a sec. The important part's up there. Anyone have any guesses? Yeah, exactly. Just like you guys did in an earlier lab. It will run a web server. You got it right. Specifically an Nginx web server. They'll like make sure the package Nginx is installed, which is what that first line does. It'll run the service Nginx. It'll require the package to be installed first, and then it uses this thing called subscribe, which is similar to require. It like, in this case, it has the class like OCF SSL, which like, what is it? Like creates SSL certificates for websites so they can run like for security stuff. You may have heard of that. So it's like a custom class that OCF made because a lot of things require OCF or require SSL certificates. So sometimes you want to make like custom modules. There's also built-in Puppet modules you can use because you'll find yourself needing to do a lot of stuff that like other people have already done before or you've already done before. And it kind of speeds things up like the function sort of template. So in this case, it's expressed the class. And then finally, it'll create, what is it? The file to configure Nginx. It'll use a template you wrote already, hopefully, before you run this. OCF outpost local conf. And that'll be the content of this other file that's located in Etsy. And again, before it creates the file, it'll require the package to be installed. And it'll also notify the Nginx service if it is changed. I believe that's what notify does. It's been a while. And yeah, subscribe will check if this particular class has been modified in any way, in which case it will make some changes. I'd have to read the documentation again to like refresh my memory, but yeah, and then there's some additional stuff. I think this is the template file that's specified. Yeah, does anybody have any questions about how this is structured? Pretty straightforward example again, hopefully. Okay, you'll be writing something pretty similar to this in the lab. So how do we use Puppet at the OCF to get you thinking more about how it's possibly used. You can see like how we set up Puppet publicly on our GitHub repo. We originally started using it in 2012, which was 12 years ago. From the configuration is edited directly on the server and desktops manually model. Okay, we had 10 desktops and we were just like manually editing all of them and configuring things the way I mentioned earlier in the dark ages. But now all of the OCS machines run off of this Puppet repository. So the desktops, the NUC behind the TV used to be there. Now we have another one that I don't think is hooked up. We have hypervisors, which used to run the VMs you guys use for your lab. And then of course the VMs themselves running all the network services we learned about, including the Puppet server itself. These are VMs we have running our services, such as like, again, club web hosting, the like GPU cluster, stuff like that. Oh, actually in 2024, we moved a bunch of things to Nix and plan to move the rest by 2025. This is true and real. Who added that? Which is another like, you know what, you're learning Puppet today. You'll learn about Nix another day. Thank you. Oh, it was you, Enja. Thanks, Enja. So yeah, Puppet at the OCF, all the code is split into modules. We've got OCF TV. Again, pretty self-explanatory. OCF desktop, OCF WWW, OCF host. And yeah, we also have some modules for shared configuration that we've used, stuff we had to reuse for multiple servers. We just made custom modules for. Yeah, does anybody have any questions? I don't think so. Give them more info. Okay. This is the final slide. There's also another, I think I mentioned earlier, configuration management tool called Terraform. Back in the day, we used to run the VMs on with this cloud provider, DigitalOcean, but there was some drama, so we don't anymore. But we used to use Terraform to generate the DeCal VMs. This is some of the code we used to do that. And yeah, the code to do is still available in the repository if you're curious. And I think it's a little better than Puppet if you're trying to provision like VMs on cloud platforms, I guess. And yeah, I think that is the end of the lecture. Yeah, does anybody have any final thoughts before I switch the lab so you can actually start working on it? Nope. Questions about the class? Okay. Yeah, you're free to go if you choose. Thank you guys for coming. No problem.